You know what I see all the time on the internet? Free energy devices, perpetual motion machines, contraptions that supposedly generate more energy than they consume, motors that run forever without fuel, magnets arranged in clever ways that supposedly violate the laws of physics. And you know what all of these devices have in common? They don't work. Not a single one. Not ever. Not even a little bit. And it's not because we haven't been clever enough. It's not because we haven't found the right arrangement of magnets or the right configuration of wheels. It's because there's a law of physics, one of the most fundamental laws in all of science, that says these devices are impossible, not impractical, not beyond our current technology. Impossible. Period. That law is the second law of thermodynamics. And today, I'm going to explain to you exactly why this law makes free energy devices impossible, and why anyone claiming to have built one is either confused or lying. First, let's be clear about what we mean by free energy. People use this term in different ways, so let me define it precisely. A free energy device, in the sense that people usually mean, is a device that produces more useful energy than you put into it. It's a machine that creates energy out of nothing, or extracts energy from some mysterious source that physics hasn't discovered yet. It's a perpetual motion machine of either the first kind, which runs forever without any energy input, or the second kind, which extracts energy from a single heat reservoir and converts it entirely into work. Now, why would we want such a device? Well, it's obvious, isn't it? Infinite free energy would solve all of our problems. No more energy crisis. No more pollution from burning fossil fuels. No more wars over oil. Just set up your free energy device and run your house, your car, your civilization forever, for free. It's a beautiful dream. And throughout history, thousands of people have tried to build such devices. Clever inventors, determined engineers, even some scientists who should have known better. They've built wheels, magnets, springs, pulleys, all sorts of contraptions, each one supposedly producing free energy. And every single one has failed. Every single time, when you measure carefully, when you account for all the energy properly, the device either stops working, or it's secretly consuming more energy than it produces. Or it's a fraud. Why? Because of thermodynamics. Specifically because of the second law. Before we get to the second law, let me quickly explain the first law of thermodynamics, because you need to understand both laws to see why free energy is impossible. The first law is simple. It says energy is conserved. Energy cannot be created or destroyed. It can only be converted from one form to another. You can convert chemical energy in gasoline into kinetic energy of motion. You can convert electrical energy into light. You can convert the potential energy of water behind a dam into electrical energy in a turbine. But the total amount of energy stays the same. You can't create energy out of nothing, and you can't make it disappear into nothing. This law alone rules out the first kind of perpetual motion machine, the kind that runs forever without any energy input. If energy is conserved, if you can't create it out of nothing, then a machine that runs forever must be getting its energy from somewhere. And if it's doing useful work, if it's lifting weights or generating electricity or doing anything productive, it's losing energy. And eventually, it must run down. So the first law says, no, you can't get something from nothing. No free lunch. No energy created out of thin air. But here's where people get clever. They say, okay, fine, we can't create energy. But there's energy all around us. Heat energy in the air, in the ground, in the ocean. What if we extract that energy and convert it into useful work? We're not creating energy. We're just taking energy that already exists and using it. And that sounds reasonable, doesn't it? The air in this room has thermal energy. The molecules are bouncing around. There's kinetic energy in all that motion. The ocean has enormous amounts of thermal energy. Why can't we just extract it And this is where the second law comes in. Because the second law says, no, you can't do that either. At least, not in any useful way. The second law of thermodynamics is more subtle than the first law, and it's often stated in several different ways. But the most fundamental statement is this. In any closed system, entropy always increases over time. Now, what's entropy? Entropy is a measure of disorder, of randomness, of how spread out energy is. Low entropy means energy is concentrated, organized, available to do useful work. High entropy means energy is dispersed, randomized, unavailable. Let me give you an example. Imagine you have a hot cup of coffee sitting on a table. The coffee has thermal energy concentrated in it. It's at a higher temperature than the surrounding air. This is a relatively low entropy situation. The energy is organized, localized. Now what happens over time? The coffee cools down. Heat flows from the hot coffee into the cooler air. Eventually, the coffee and the air reach the same temperature. The energy that was concentrated in the coffee is now spread out throughout the room. This is a higher entropy situation. The energy is more dispersed, more randomized. And here's the crucial point. This process is irreversible. Heat flows spontaneously from hot to cold, never the other way around. You never see a cup of coffee spontaneously get hotter by extracting heat from the cooler air around it. That would decrease entropy, and the second law says entropy must increase. Now, why does entropy always increase? Why is this a law? The deep reason comes from statistics and probability. There are vastly more ways for energy to be spread out randomly than for it to be concentrated in an organized way. When you have trillions and trillions of molecules bouncing around, the overwhelming probability is that they'll end up in a high entropy configuration rather than a low entropy one. It's not impossible for entropy to decrease locally and temporarily. It happens all the time. When you freeze water, you're decreasing its entropy, creating more order. But you only do that by running a refrigerator, which dumps even more entropy into the environment. The total entropy, system plus environment, still increases. Now let's apply this to free energy devices. Specifically, let's see why you can't extract useful energy from a single heat reservoir, like the air or the ocean, and convert it entirely into work. The second law tells us that heat naturally flows from hot to cold, and when heat flows, you can extract some of that energy and convert it into useful work. That's how all heat engines work, whether they're steam engines, internal combustion engines, or power plants. But here's the key. You need a temperature difference. You need a hot reservoir and a cold reservoir. Heat flows from the hot reservoir to the cold reservoir, and your engine sits in between, extracting some of that energy as useful work. Without a temperature difference, you can't extract work. You can't take a single heat reservoir at uniform temperature and extract its thermal energy to do useful work. That would decrease the entropy of that reservoir without increasing entropy somewhere else, and the second law forbids that. This is why you can't power a boat by extracting thermal energy from the ocean. Yes, the ocean has enormous amounts of thermal energy, but it's all at roughly the same temperature. There's no temperature difference to drive a heat engine. To extract energy from the ocean, you'd need to find something colder than the ocean, dump heat into it, and use the temperature difference to run your engine. But then you're not getting free energy from the ocean. You're getting energy from the temperature difference. Some people say, well, what about the temperature difference between the ocean surface and the deep ocean? Can't we use that? And yes, you can. That's called ocean thermal energy conversion, and it's a real technology, but it's not free energy. The temperature difference exists because the sun heats the surface. You're really extracting solar energy, not creating energy from nothing. The second law is absolutely clear. You cannot build an engine that extracts heat from a single reservoir and converts it entirely into work with no other effect. This is called a perpetual motion machine of the second kind, and it's impossible. Now, let's talk about efficiency. Even when you have a temperature difference, even when you're building a legitimate heat engine, the second law puts limits on how efficient that engine can be. There's a theoretical maximum efficiency for any heat engine, and it's called the Carnot efficiency. It's named after a French engineer named Carnot, who figured this out in the 1820s, before we even fully understood thermodynamics. The Carnot efficiency depends only on the temperatures of your hot and cold reservoirs. If your hot reservoir is at temperature T hot and your cold reservoir is at temperature T cold, measured in absolute temperature using Kelvin, then the maximum possible efficiency equals 1 minus the ratio of T cold divided by T hot. Notice what this tells us. If T cold is greater than 0, if your cold reservoir is above absolute 0, then your efficiency is less than 100%. You cannot convert all of the heat energy into work. Some of it must be dumped into the cold reservoir as waste heat. And if T cold equals T hot, if there's no temperature difference, then the efficiency is 0. You can't extract any work at all. This is a fundamental limit. No cleverness, no engineering tricks, no fancy materials can exceed the Carnot efficiency. It's a consequence of the second law, and the second law is a consequence of the statistical behavior of matter. Real engines, of course, are less efficient than the Carnot limit. They have friction, heat losses, imperfect timing, all sorts of practical problems. But even a perfect idealized engine can't beat Carnot. So when someone shows you a device that claims to exceed the Carnot efficiency, you know immediately that they're either measuring wrong or they're lying. The second law doesn't allow it. Let me walk you through some specific free energy schemes and show you exactly where they fail. Magnetic motors are popular. People arrange magnets in clever configurations, claiming that the magnetic forces will drive a rotor perpetually. And indeed, you can make configurations where magnets push and pull in interesting ways. But here's what always happens. Either the magnets reach an equilibrium and stop moving, or you have to put energy in to reset the configuration for the next cycle. Magnets don't contain unlimited energy. A magnet is a piece of matter with aligned magnetic domains. The alignment represents a low entropy configuration. But the magnet doesn't produce energy on its own. When magnets push or pull on something, they're converting magnetic potential energy into kinetic energy. But once the system reaches equilibrium, once the object has moved to the lowest energy configuration, it stops. No perpetual motion. Then there are overunity devices, machines that supposedly produce more energy than they consume. Usually, these involve some form of deception, intentional or otherwise. Hidden batteries, external power sources that aren't being accounted for, measurement errors that overestimate output and underestimate input. I've seen devices that supposedly extract energy from the Earth's magnetic field. But the Earth's magnetic field doesn't carry energy flux. It's a static field. You can't extract energy from it any more than you can extract energy from a permanent magnet sitting on a table. Yes, the field exists, but it's in equilibrium. There's no energy flow to tap into. Some people claim to extract energy from the quantum vacuum, from zero-point fluctuations. And yes, quantum mechanics says there are fluctuations in the vacuum, temporary violations of energy conservation on incredibly short timescales. But these fluctuations average to 0. You can't extract macroscopic energy from them. Some people point to the Casimir effect as evidence, but the Casimir effect doesn't produce energy. It's a force between plates, yes, but once the plates move together, the system is in a lower energy state. You got some energy out, but now you have to put energy back in to separate the plates again. No net gain. Every single free energy scheme, when you examine it carefully, either violates the second law, which means it doesn't work, or it's secretly getting energy from somewhere that's not being acknowledged. Why is the second law so ironclad? Why can't we find a loophole? Why can't we be clever enough to beat it? Because the second law isn't really a law in the same sense as, say, force equals mass times acceleration. It's a statistical certainty. It emerges from the collective behavior of enormous numbers of particles. When you have a cup of coffee cooling down, what's really happening is trillions upon trillions of molecules colliding, transferring energy, spreading that energy out in increasingly random ways. And while it's not strictly impossible for all those molecules to spontaneously organize themselves to make the coffee hotter, the probability is so absurdly small that it will never happen in the lifetime of the universe. Imagine shuffling a deck of cards. It's possible, in principle, to shuffle the cards and end up with them in perfect order. All the spades, then all the hearts, then all the diamonds, then all the clubs, each suit in order from ace to king. But the probability is incredibly tiny, one in a number with more than 67 digits. You could shuffle cards for billions of years and never see this happen. The second law is like that, but vastly more extreme. You'd have to wait not billions of years, but timescales longer than the current age of the universe raised to insane powers, to see a spontaneous violation of the second law in any macroscopic system. So when someone claims to have built a free energy device, they're claiming to have beaten statistics so overwhelmingly unfavorable that it's effectively impossible. They're claiming to have found a way to make trillions of molecules all conspire together to violate their natural statistical behavior. It doesn't happen. It can't happen. The numbers are against it in the most absolute way imaginable. Now you might ask, if free energy is impossible, why do people keep claiming to have invented it? Are they all frauds? Some of them are frauds, yes. Some people know their devices don't work, but they promote them anyway to get investment money, to sell books or videos, to gain fame. That's just dishonesty, and it's despicable because it preys on people's hopes. But many free energy inventors are sincere. They genuinely believe their devices work. They've built something, they've measured it, and they think they're seeing more energy out than in. What's happening is usually one of a few things. Measurement errors are common. Energy is tricky to measure accurately, especially when you have multiple forms of energy involved. Maybe they're not accounting for all the energy inputs. Maybe there's a battery running down that they haven't noticed. Maybe friction is less than they estimated, so their device runs longer than expected, and they interpret this as free energy. Or maybe they don't understand the physics. They see their device doing something counterintuitive, something that surprises them, and they leap to the conclusion that it must be violating known physics. But physics is subtle. There are lots of phenomena that seem paradoxical until you understand them properly. The problem is that once someone has convinced themselves they've built a free energy device, they become invested. They've spent time and money. They've told people about it. Their ego is involved. And so they resist any explanation that says, no, you made a mistake. They'd rather believe that physics is wrong than that they made an error. So let me be absolutely clear. Free energy devices are impossible. Not difficult. Not impossible with current technology. Just impossible. Impossible in the same way that a ball rolling uphill spontaneously is impossible. Impossible in the same way that time running backward is impossible. The second law of thermodynamics says that entropy always increases in closed systems. This means you cannot extract useful work from a single heat reservoir. You cannot build a machine that produces more energy than it consumes. You cannot beat the Carnot efficiency. You cannot create a perpetual motion machine. These aren't just engineering challenges. They're fundamental constraints built into the structure of reality itself. They're consequences of statistics, of probability, of the fact that there are vastly more disordered states than ordered states. Could the second law be wrong? Could there be some deeper physics we don't understand that changes everything? I suppose it's possible, in the same way that anything is possible. But the second law has been tested more thoroughly than almost any other principle in physics. It underlies everything from engines to biology to black holes. If it were wrong, we'd see violations everywhere. We don't. So the next time someone shows you a free energy device, the next time someone claims to have built a machine that violates thermodynamics, you can be absolutely confident that they're either mistaken or lying. You don't need to examine their device. You don't need to check their measurements. You just need to know the second law, because the second law doesn't care about clever engineering. It doesn't care about your magnets or your wheels or your mysterious energy sources. It's a law of nature, as fundamental and unbreakable as anything in physics. And that's beautiful, in its own way. Nature has rules, real rules, rules that can't be broken no matter how clever you think you are. And understanding those rules, accepting those rules, working within those rules, that's what science is all about. You can't have free energy. The universe doesn't work that way. But you know what? The universe works in ways that are even more interesting, even more profound than any free energy fantasy. And that's enough for me. Thank you.